Important, difficult question from test point of view on rational expressions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken up a challenge question based on rational expressions. Normally, in a test paper, you'll find one very difficult question, and this is one of those. So I'm calling this as a bonus test question. X minus 3 over x minus 5 is equals to p plus q over x minus 5. Find the value of p and q, that's part A, and then find integer coordinates on the graph of y equals to x minus 3 over x minus 5. You can use the answer in part A to find the solution for part B also. Now let us see how do we solve such a question. It's kind of a new question, not given in many books. So let's try to do part A, which is find the value of p and q. The rational expression given to us is x minus 3 over x minus 5. And we need to write this as p plus q over x minus 5. Now, one of the methods is that we can expand the right hand side and then compare and find the value of x, right? I mean p and q relating to the expression. So that is what we'll do, which I'm saying method 1. Method 1 is not very efficient. So method 2, which I'm going to follow immediately after, will be something you'll really love. Okay, so this is a normal way of doing it. So we could take common denominator, multiply p with x minus 5, and then we have plus q here, right? So when you expand this, you get p times x minus 5p plus q in the numerator and x minus 5 in the denominator. So if you compare the coefficients, you can very clearly see that there is only one x here, right? So px means p should be 1, correct? So comparing, we get p equals to 1. Is that clear to you? Now the other part here is minus 3 should be equals to minus 5 pi plus q, right? So let's do that part. So we have minus 3 equals to minus 5p plus q. Since we know that p is 1, I could write this as minus 5 plus q, right? Since p is 1. So let me write in brackets 1 for p plus q. And that will give you the value of q, which will be minus 3 plus 5. And that gives you 2 as the answer. So basically, I could write this as 1 plus 2 over x minus 5. Is that clear to you? So that becomes part A. Now let me show you the second method of doing it. There are many actually. You could simply divide x minus 3 by x minus 5 and get the result also, right? So we'll do that also, right? Okay. So here is your second method. Mathematics is all about learning different strategies to solve questions, right? Now, in case you want to really learn from me, you can directly send an email on the address given. So look here, the beauty of this method. We are given x minus 3 over x minus 5. Since I want a whole number here, p, right? So what should I do? I should write minus 3 in terms of minus 5, right? So I could write this as x, and I could write minus 3 as minus 5 plus 2. Makes sense? Minus 5 plus 2 is minus 3, right? And so what I get is x minus 5 over x minus 5, right? Plus 2 over x minus 5. Or you can say 1 plus 2 over x minus 5. Do you see that? So again I got the same result, which is p is equal to 1 and q is equal to 2, right? Now let me give you a third method also. I think you like that also, right? There are many ways, as you can see, to solve a question. Sometimes you understand some strategies better than other. Sometimes, as per the context, you have to apply the correct strategy. But you should be aware, right, of these. So the third strategy here is to divide x minus 3 by x minus 5. If I do so, it goes one time and you get x minus 5. This is log division. And you get 2 as your remainder. And clearly, I could now write x minus 5 over x minus 3 over x minus 5 as 1 plus. We still need to divide 2 by x minus 5. Do you see that? So this is long division. You could even do that, right? Very effective strategy. So you see, we have done 3 different ways of solving part A. A very important test question. Perfect. Now let's do part B and understand what is the meaning of integer coordinates on the graph of y equals to x minus 3 over x minus 5. So in the previous example, part A, we got this as 1 plus 2 over x minus 5. Now we are looking for integer coordinates on the graph of y equals to this. What do we really understand? It really means that for integer values of x, we should have integer values of y. Now 1 plus this part, which is 2 over x minus 5, when can that be an integer? This is what you have to think. So basically, you have to make this as an integer. Now, that is possible. That is possible if I make x minus 5 as 1, then I get 2 as my value here, right? I could also make x minus 5 as minus 1, correct? I could do that also, right? So this is one, so we can have case 1. We have x minus 5 equals to 1. And that is possible when x is equal to 1 plus 5, which is 6. Makes sense, right? So clearly, if I make x minus 5 as 1, then the y value, in that case, y value will be 1 plus 2, right, which is 3. So the integer values we get is 1 and 3, correct? Now let's take the second case when x minus 5 could also be minus 1, right? So in that case, x will be minus 1 plus 5, or you can say plus 4. So in that case, y will be 1 minus 2, right, which is minus 1. And so we get minus 1 as one of our points. What else? Well, x minus 5 could be plus or minus 2 also, right? So we have case 3, which is x minus 5 equals to 2. And that gives you the value of x as 2 plus 5, which is 7, or y equals to 1 plus 1, right, which is 2. So the integer value for the coordinates is 7, 2, right? And the last case which I am going to take is the case when x minus 5 is equal to minus 2, right? In that case, x will be equals to minus 2 plus 5, which is 3, and the y value will be, since x minus 5 is minus 2, will be 1 minus 1, right? 0. So that gives me minus 2, 0 as the other values. So there are 4 integer values, as you have seen here. Perfect. Amazing. Very interesting question. So we have 4 integer values. For the coordinate points on the graph of x minus 3 over x minus 5. Perfect. So I hope that makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great.